poster of a Jasper Johns painting 0 through 9. So all the digits 0 through 9 are showing in this poster right here. Kind of interesting. I really like the colors. So what we have here is a function x to the 2/3 over x to the 1/3 plus x, and we want to find the derivative. So what I see is the quotient rule, and then I also notice I have these fractional exponents. So I'm going to be very careful when I take this derivative to make sure I differentiate correctly. But the main thing that I see here is the quotient rule. So let's apply that. It's going to be the denominator, x to the 1/3 plus x times the derivative of the numerator. So I'm going to take the exponent out in front, 2/3, x to a power 1 less. So I'm going to subtract 1 from that exponent, and what I get is negative 1/3. So that exponent is negative 1/3 minus, now I'll take the numerator just as is, x to the 2/3, and differentiate the denominator. Okay, so when I differentiate x to the 1/3, the 1/3 comes out in front. X to a power 1 less, so 1/3 subtract 1 is going to be negative 2/3, plus the derivative of x is just 1. And all that is divided by the denominator squared. X to the 1/3 plus x all to the second power. So let's see, did I do that right? X to the 1/3 plus x times the derivative there. X to the 2/3 subtract 1, I get negative 1/3 minus, because that's part of the quotient rule, the numerator just by itself, no change, derivative of this, 1/3 x to the negative 2/3, that's right, plus x, all divided by that. Okay, so if you get this right here, you can do that part. You're good with the calculus. That's all there is to it. You've applied the quotient rule correctly. Now, the simplification of this is all algebra, and sometimes you want to simplify, and there's other kinds of problems where you may not. It depends on what comes next. If you were asked to find f prime at, let's say, 9, well, you wouldn't necessarily simplify this because you're just going to substitute in 9 for x and simplify what you get there, and that will probably be easier. If you're looking to set this equal to 0 and find the values of x that make this expression 0, then you want it as simple as possible. So in the real world, when you find these derivatives, sometimes you simplify and sometimes you don't. We're going to simplify right here just for the practice of it to see what we can do and how we can get this to be simpler. So what's the biggest problem I see right here for myself trying to simplify? I don't like these negative fractional exponents. But I look a little closer and look what happens if I multiply x to the negative 1/3 times x to the 1/3. I'm going to add exponents. That exponent is going to be 0, and I'll be just left with x to the 0, which is 1. When I multiply x to the 1/3 times x to the, remember that exponent is 1, I add exponents, I'll have x to the 2/3. At least it'll be a positive exponent. So maybe that's a good idea. What happens over here? X to the 2/3 times x to the negative 2/3. Again, the exponent is 0, so I end up with x to the 1, with x to the 0, which is 1. And then x to the 2/3 times 1. Maybe that's not too bad. So let's take a look and see what we get here. I'm going to multiply this times this, and I'll get 2/3. X to the 0, which is 1, I'll just write down x to the 0 for right now, plus 2/3 times x to the 2/3. When I add 1/3 and 1, I get 2/3. So at least I've got rid of the negative exponents. And look, if this doesn't work, I'll try something else. So now minus x to the 2/3 times 1/3 x to the negative 2/3, that's going to be 1/3 x to the 0, minus, I'll take the negative sign with it, times 1 x to the 2/3. Okay, so that's all over x to the 1/3 plus x to the 2. So look, this isn't too bad actually, because x to the 0 is just 1. X to the 0 is just 1. So I have 2/3 subtract 1/3 1/3. And here I have 2/3 x to the 2/3 minus 1 x to the 2/3. So 2/3 x to the 2/3 minus 1 x to the 2/3 is going to be minus 1/3 x to the 2/3, all divided by x to the 1/3. Is that staying on the screen? Yes. Plus x to the second power. So, boy, that's simplified very quickly just by multiplying this out. So why did I decide to do that? Because I looked at the part of this expression that I liked the least and just asked myself, how could I change these exponents to positive numbers instead of negative numbers? So it turns out when I look at the distributive property, distributing this over these two things and this over these two terms right here, it turns out that all the exponents turn positive, and in fact it simplifies very nicely. So I'm just going to multiply numerator and denominator here by 3, so I'm going to end up with 1 minus x to the 2/3, all divided by 3, x to the 1/3 plus x squared. So I don't know if that's going to be easier to work with or not, depends on what I would want to do next with this, but there I have succeeded in simplifying this down to something that at least has only positive exponents. My original problem had fractional exponents. My answer has fractional exponents. I think I'll just leave it that way.